So, it is a very simple idea. The same thing we can do for speech also, right. First, I will start with a simple speech recognition problem, and then I will talk about a more complicated problem. Okay. So, let us say that in my language there are only two sounds that are produced, A and E. Okay, A, E. So, I only produce two sounds. Okay. So, this is a special language. It's called, it's Umesh's my language, a special language that I have invented. There are only two languages, A and E. Okay. So, in this in this language, in this special language, I have only two sounds. Okay, A and E. Okay, this is some notation we use for A and E. Okay, so let us say the Hindi version of this is A and the Hindi version of this is E. Okay, A, E, that is all. Okay, two sounds that I produce. Okay, now I am giving you a pattern classification problem. So, given sound file, right. So, this is a waveform, whatever it is, waveform, some waveform. Okay. So, this is in time. I have to decide, classify either A or E, classify. That is my problem. So, it is a binary classification problem, right. So, what do I do? What from whatever we did here for heights, weights and all, same thing we are going to do for our guys also, right. So, what did we do? We needed some kind of features, right, and then we it could be that the features have multiple mixtures. So, we could have mixture of Gaussians, and then we compared the GMM for built a model for men, built a model for took all the heights and weights of Indians, built a model for Gauss males, took the heights and weights of Norwegian, built a model for them, took the heights and weights of Pygmy, built a model for them. So, these are the models that are already built. This is supervised data. I know these heights and weights came from the Indians, therefore, I could build a model for them. I know these heights and weights came from Norwegians, therefore, I built a model and so on, right. So, what do I do here? Same thing I do. Okay. So, how do I do that? So, I need to classify between these two sounds. So, first thing is we have to extract features, right. So, how do we extract features? We extract features, we know only three things, right. If I am using deep learning, I will use something called Bell filter bank. It can be two things. Basically, the wide band will be 80 ml filter bank, or the narrow band will be 40 ml filter bank, log band filter bank. Or if I am going to use some kind of a Gaussian mixture hidden Markov model, I will use this idea of MFCC. These are only two things I have been taught, so that is all I will do. Okay. So, I am going to do this analysis. So, I will take intervals of this thing, right, and then I will extract the feature vectors. So, let me call these as feature vectors O1, O2, O3. These are, let us say, MFCC vectors, features, MFCC features. So, these are usually 39 cross 1. Okay, these are all 39 cross 1. Okay. Now, obviously, I have to build a model for A and build a model for E, right. So, I have to build using MFCC features these are the only two sounds in my language, right. So, I have to build a model. So, I need now training or supervised data for building the model, right. So, I need data with labels, right. So, what I will do, I will catch 1000 guys. Okay. So, this is like, remember in the heights and measurements, I had this idea that this was 5 feet 8 inches was man, 5 feet 1 inch was women, 4 feet 9 inches was women, 5 feet 6 inches was man, 6 feet 1 inch was man, like that. This is labeled, right? This is a label. So, here I am asking people, so I will get one measurement 1 S1 of T, which is from R, right, like that, S 1000 of T R, and each one of them will give me some MFCC vectors, right, something like this. So, these are my, let us say I only generate one vector, let me not confuse you with the concept of sequence here. So, we get one MFCC vector for each one of them, right. So, using this, now these are the features which is like a measurement, like heights and weights are two-dimensional measurements, right. So, belonging to man. Here this belongs to R, this is another man's voice, another woman's voice. I am not separating man or woman here, I am only separating sound R versus sound E, okay. So, all these are labeled and these are the feature vectors. So, this is how I create my set of features for R, right. Similarly, I will take another 1000 guys and say E, okay. So, I will get another waveform here, which will be for the E sound, which will be S1T all the way up to some S1000T, right, and therefore, I will use this and I will generate the MFCC vector, but now I know this is labeled data. This belongs to sound E, this belongs to sound E, and so on. So, 1000 measurements I have, right. So, now I have measurements for R and measurements for E, right. So, the two sounds I have, these are the two phonemes that we talk about in speech, right. And because like we said, heights and weights can come from populations like children, men, women. Here also the problem is I didn't note down whether it's a man or woman or child, and therefore the features, because the physiology is different, right. Men are have longer vocal tracts, women shorter, and child even more shorter. There will be some differences, okay. But we are only looking at the R and the E sound without worrying about what is happening here. So, what we do is we build a GMM, but this is now a multivariate. This will be like 39 cross 1, there it was some 3 cross 1 or 2 cross 1. Here it will be a GMM for the R sound, and similarly here we will build a GMM for the E sound, okay. So, now we have two models, one is a mixture of Gaussians for whatever you did for the single class, the same idea will hold true for the multiple bivariate. There we talked about, not to confuse you, when I talked about mixture of Gaussians, I took the simple example of height, which is a univariate, right, only one variable is there. I could have extended it to heights and weights, nothing much changes, okay. Still it will be the idea of initializing with some random weights, finding out which of these three components it belongs to, then that becomes a missing information. Now we get either the soft assignment or the hard assignment, update the means and variances and all that, and keep repeating it. GMM is always some kind of an iterative process. The expectation maximization kicks in, but for a multidimensional feature vectors, okay. So, again we have now a good model for men and for R and E, but this is now a mixture of Gaussians, okay. Now, if an unknown test sound comes, so this is my unknown test sound, S test. As usual, I will extract the MFCC vector. So, this is MFCC test, okay. Now, in my language, there are only two categories of sound, R and E, correct. So, I will take this MFCC, so I will compare GMMR with this, let me call this as O test instead of MFCC test, okay. This is a vector O test, the observation vector O test with the model parameters for R. When you say model parameters in a GMM, what is it? Mean, covariance matrices, weights, and so on. and similarly versus GMM for the E sound, again the same O test vector with the parameters of the E GMM, and whichever is larger, I will say that it belongs to that class. So, what are the things that you have learned? I can distinguish sounds if there are only two sounds. Now, sounds are nothing but phonemes, right? So, if there are two distinct phonemes, right, say A and E, I am now telling you how to develop a method, an automatic method by which you can classify a given sound without knowing it, right, into one of these two. In my language, there are only two sounds, A or E, that I know. So, the way I will do is first extract the MFCC vector. In this case, I am talking about MFCC. For other applications, maybe you could use Bell filter bank, some kind of a representation, right. Then this is what we call the feature identifying the sound, right. The MFCCs are capturing the underlying vocal tract, I mean the mouth information, right. So, they do capture a lot of information about the particular sound, A versus E, right. So, there is some distinct changes in the frequency, and therefore, the MFCC vectors we know will be different. So, these are capturing the frequency aspects of the sound. So, I take then lots of measurement from people, it can be children, men, women and all that, saying the sound A, and therefore, the MFCC vectors will come, and I will get a collection of so many vectors, 1000 vectors or something. From that, because it can be variations due to men, women, child, environment, so many other things, I use a mixture of Gaussians to get the sound A, right, a model for the sound A. Similarly, I take lot of measurements by asking people to say E, right, and take lots of measurements from the people who say these sounds, right, and then build a model, Gaussian mixture model for E. So, now I have these two sounds very nicely modeled. Now, an unknown sound comes, right, a test sound, right. I do not know, but my problem is very simple, categorize, say whether it belongs to the A category or the E category, that is all. So, I have to just compare the probabilities with these two, the likelihood of the one of these two functions, density functions generating that particular observation, and whichever is most likely is we will say it belongs to that particular class, that is all. Okay. So, this is now we have reduced this problem to very simple. So, we can start using some automatic ways to identify sounds. Okay. So, this is the first step, but in speech there is a problem, right. So, whatever I have described till now is like saying I want to separate out in the written language, right, A versus E or something, right, only two letters. And so, depending on how I write, I can take, people ask to write A, E, and so on, and we can identify the sound. Okay. But the problem in handwriting recognition is that when I write like something like this, right. So, now not only I am having more classes. So, now there will be 26 classes to worry about, correct. So, now my pattern recognition problem becomes that there are 26 character sounds to be 26 classes. But when I give a test, there is not one, it is a mixture. I mean, all these guys, when I am looking at this whole sentence, right, I am not, in this case, when the return came, I have to identify whether it is A or E. There are only, whenever I wrote something, there was only one letter I wrote, right, and therefore, I have to distinguish that letter whether it was an A letter or E letter if I am doing written handwriting recognition. But when I have written a sentence, right, my problem is not identifying one of those 26. First of all, I do not know how many characters are here, that itself I do not know, right, because I only get this sentence, I cannot say that this has ended, and therefore visually I know that I can count, okay. But in an automatic method, I have no clue whether there are 50 characters here or a concatenation of 50 characters, 1 character, 10 characters, 100 characters. First of all, I don't know how many characters are there. Secondly, I don't know where one character ended and where another character started, right. So, all these are issues which is in cursive writing, right. In handwriting, in printed one, it's very simple. In printed one, it becomes very simple. Why? Because you will write it like this, okay. In printed, I have, the way we print it, this is, I mean, I should, let's not worry about case, okay. Let's say all are lower case only, okay. In printed, this job is very, very easy. This is one character. Actually, there will be a larger space. This is a blank between words. Okay. Then this guy comes. This is the next character. Between the next character and this character, there is a distinct space. A small space will be there. You can see in cursive writing that's not there. We can use image processing and say wherever there's a complete, blank, right? That is the end of one character, right? So similarly, there's a blank for the word. There's a blank for the separation between the characters. So the characters are well separated by blanks. Therefore, here it becomes very easy for me to separate out into characters, and then I can ask each one of these characters, does this belong to one of those 26 classes? This belongs to one of those 26 classes. This belongs to one of the 26 classes, and so on. So then it becomes a very, very easy problem. But in handwriting recognition, that is not at all clear. I am not at all clear if this is one character. Where did one character end? I don't know. Where did the next character start? Is there one character, two character, 5 character? All that information is, it's not very easy to automatically distinguish the characters, okay, and therefore it's a much more difficult problem. So this is called sequence problem, okay. So there is a sequence of units, sequence of events occurring, sequence of characters that are happening, sequence of sounds that are happening, but I don't know how many, how are they separated, where are they separated, all that is not at all well, I mean, I cannot isolate them, okay, and that is a big problem in sequence modeling, okay. So now how are we going to deal with this idea of sequences, and what do we do? So the same idea of spoken, when I speak, I don't say the g o. If I had done like that, then problem is very, very easy, right? Then everywhere between d. So there's a gap. Then I'll say, okay, was one sound, second sound, d, third sound. So there's a distinct silence between what I say. I'll use that to partition it, and then which is one of the 45 different phonemes, which is one of the 45 phonemes, d, which is one of 45 phonemes. That is very, very simple problem, okay. But when I say and, it's all continuous. I don't know now, you are, as a human, you're used to hearing the sound and. So there are three boss, I know there are 3 letters, right? There are 3 sounds. That is not. So imagine it's a dumb machine. So you went to a different language, right? Or you click language, something like that, there's a click language in South Africa, right? There you don't know what sound is, whether one sound is merged with the other sound or it's ended. So when you don't know, even though you have a powerful supercomputer sitting on your brain, even you are not able to, forget it, even if you knew all the sounds, right? When you go to Chinese, right? Can you spend 1 or 2 months in China just to sit there, listen to the Chinese speaking, and can you start speaking Chinese? It's very difficult. Children can do it because they are, their neurons are developing, and so they can quickly absorb. Once you're past 20-25, right? You go in China, how much ever you try, there will be, first of all, you cannot produce half the sounds because you're been trained. That's why I'm saying language is so difficult, right? Once you go to China, the Chinese can never say r. For him, he thinks he is saying r. For him, even the ear interprets. The brain is thinking he's saying ra, but he'll always say l. Narayan, no, lion. So ra, he'll say how much ever you try. And similarly, we also make mistakes. How much ever we say Indians, we say vegetable. We don't say vegetable. We'll say vegetable, which is actually an American will get confused, because to us, how much ever I say vegetable, I think I'm saying verse sound correctly. For him, there's a very distinct van versus water. Okay, there's a very distinct w, v and o. Okay, there's a very distinct sound which you cannot distinguish or even produce. For example, Tamil guys cannot produce. So when you have a Hindi person, he can say, I think bhai, right? Even I can say or khadag, right? Khadag. I cannot, a Tamil person cannot produce, because we have only one ka. We'll say khadag, khadag. We'll only say it longer. That sound, that the tongue has to go to a different position, we cannot, because we have been trained when we speak a particular language. When you grow up, you know only one way of producing. So you think ka means only that way, right? But for a Hindi guy, he knows it's k and kh. They aspirate and it has to go back, right? So language is, I mean, you learn, right? And so imagine a dumb machine. I mean, how many hours of speech? Even if you give 1,000 hours of speech, right? It's what, a few days of worth of speech. So that's what I said. If you sit in China and expect to learn Chinese just by listening for 2 months, you cannot. And that is what we are expecting machines, automatic machines, to do it, right? It is a difficult job. So we have to be sympathetic to machines. They will make mistakes. So I am from that field. I know how difficult the problem is. So, but we are making tremendous progress. So we hope that we will develop a very good system that can recognize. We do have, I will show, right? We, in our own lab, we have built very good systems for technical lectures itself, right? So I will give you some demos later somewhere in the course, right? So the idea is, because it's coming to the end of this lecture, I'll stop here. I'll start from here. This is the basic problem in the sequence approach, right? I don't know where one thing ends, where another thing starts, how many are there, all that information is not missing. I'm going to guess and try to do something, okay? So that I'll stop here. Thanks.